Yeah.
Now, the test is Wednesday, and we have all of 10 to go through. Are we going to get through all of it today?
We're going to do what we can.
And then is the test just...
We're going to do it out of order, actually, a little bit. We'll see. It all depends on how far we make it.
Some problems.
I'm not going to say a damn thing right now. We're going to see where we end up today. But I want to do, to make it make a little more sense, we just came out of the section where we graphed two lines and saw where they intersected, right? You guys with me?
Yes.
To solve the system of equations, one way to do it is graphically. You can graph the lines and see where they meet.
Yeah.
Cool? Sort of? So let's do a real quick problem like that before we get... We're going to do 10.3 next, because it comes right off of that. And it just makes more sense to me. So we'll just correct the author's mistake and do that one next. But real quick...
Is there a way to make your problem equal, like the y equals, and then graph on your calculator and find that points where?
Yeah, I'm going to show you today, actually.
Okay.
Yeah, we'll get some into graphing today on the calculator. Let's see. All right, that's cool. That'll work out.
Oh shit.
Doing stuff.
Over here in the world.
So we'll get fine points, correct?
Yeah, good.
So on the test, you're going to say solve graphically or solve...
Oh, yeah. Because the other two ways we know to solve this are what two ways? Substitution, elimination, love it. But they both are based on the idea of graphically, because I can always answer the question with a point. And that's where they would meet if I graph them. Right? So what do you do with this one first here? Yeah. So if I add y, subtract 3, I get... So now I can graph them both easily, right? What's the y-intercept for this guy? -1. And then I go where? What's the slope?
1.
I like it. So then I go
1.
up 1, over 1. I can go down 1, back 1. That would be -1 over -1, which is still 1. You guys kind of with me?
Yes.
It's kind of a hint. Do more than just once. Because you're trying to see where the lines meet, and if you're at all like me, my line kind of curves a little bit.
Yeah.
So if I just do a couple points for myself, and then I do a couple points for the other line, and I'm like, where the hell's that? 7.2? No, that's crap. So give yourself more specific steps so you see exactly where the line is. So that's line number 2. Oh crap. Make your points bigger. So this is 2. What about number 1? What's this y-intercept?
Negative.
Negative 3. And then I go up
Up
2 over 1. Up 2 over 1. Sweet! So then you can see exactly where they match up.
So you want to see that when we do the solve graphically.
Yes. Cool. So what's the answer?
2, 1.
2, 1. So what's that point supposed to do?
That's your intersection point.
What's it supposed to do algebraically?
Oh, it should equal.
Like,
If you put them in there, it should.
Yeah, if you plug it in, you should get a true statement. So twice 2 minus 1 is 3. And then 1 is 2 minus 1. Right, so if you plug those coordinates in, x and y, it should make both of these work. Yes.
I think slope is negative 2.
For this one?
Yeah.
You gotta be careful. So did you subtract 2x? So when you solve for y, did you subtract 2x over? So then you get negative y equals negative 2x plus 3. So you gotta divide by negative 1. Yeah. You guys kind of with me? That's why you don't do that. You just add the y. Make the thing you're trying to solve for positive. And actually these just kind of switch places, don't they? It's a neat little shortcut. How we doing? Is it right? Okay. What else do I want to say there? I can't remember what's going. Let's see. So that's not too bad. What if the intersection comes somewhere disgusting? This is sort of like what somebody was asking me. I'm going to show you how to do this on the calculator. It's no good. I want the exact. I want the answer. Right?
Use a calculator.
What if the intersection came like here? Then you say at one point intersection come. So the answer is really 1.67993, comma 2.4444448. I am not going to get that from my especially not me.
I'm gonna give it a problem like that.
Oh hell yeah! But the thing is, you'll be able to use your calculator, right? So I'm going to show you right now. We'll do this one first, just to kind of make sure we trust the calculator. We should get the answer 2-1.
Yeah, we do.
Okay. Because if we don't, we just throw the calculator away. $100 down the drain, see that? Give it back to whoever you are. It should only be like 20 graphic calculators out in the world because everybody borrows them. So you guys watch the game?
Yes. It was awesome. At first it was like, damn, really the Heats are doing that good? Then out of nowhere.
Spurs just wanted to give them a little bit.
Like the first quarter.
If only it was a 12-minute game.
It would have worked.
All right, I'm sorry. Everybody hates basketball. I'll stop talking about it. So let's try to recover what we got here. So I'll put in there x minus 1. I didn't bring my calculator, so if you don't have yours, just watch. All right, real quick. Let me make sure everybody knows what I got there. So turn it on. Y equals is your graphing area. So let me just know if you got anything different from what I've got. If there's anything in there, go ahead and clear it out of the way so it doesn't show up and freak us out on the screen. Okay, I'm going to put in there x minus 1. X is right there. Minus 1. And then 2x. Minus 3. Anytime you put new stuff in, you should do zoom 6 for the standard window, so you don't have some freaky window from if we move stuff around. All right, I talked about that last time. All right, I like the reaction. So it looks like, I mean, here's 1, 2. It looks like everything's happening right there, right? So one thing I want to show you right here is the zoom feature. Personally, I like zoom box. So if you do zoom box, if you hit the zoom button right there in the middle, number 1, what happens is a little cursor comes up, and that's going to be one corner of my little zoom box. So if I hit enter, put the cursor about right there, hit enter, and then I go down and over, it's going to open up a little box for me. See that? So I can kind of zoom in on where interesting stuff is happening on my graph. Because sometimes graphs move very fast or they're very close together. So if I hit enter, there's one line, there's the other line, and it looks like it is 2, 1. How we doing, you guys?
Can you do the box part again?
Sure.
Any way of
So let me do zoom 6, let me get it back to normal. Alright, here comes the zoom box. Hit zoom, number 1. And the cursor is going to represent a corner of your box. You with me? So wherever you put it, if I hit enter, it's now locked in a corner of the box. So now if I go down and over, it's going to open up my box. Down, over. Just capture the area that I want. Yeah. It's like Google Maps with more control. Right? Yeah. I wait for somebody to do this on the screen.
It's amazing we don't have calculators to do that.
the other equation. 2x minus
Technologies we have, I can't.
Sure they do. Just all be like touch screens and
Not really, because if I need to do it, dude, if he goes to single one, I just go.
Down move
Yeah, well, I think we really find a way to. Oh, shoot that. No, can't do that. You gotta do it.
If I need to do it.
Alright. But I want you guys to realize this is not satisfactory. This is not enough. I'm still eyeballing the damn thing. Maybe it really is 2.0000001, comma 0.999999992. Right? I'm still human. It just looks like 2.1 to me. So I need a very precise way to find exactly what the hell it is, just in case it is something freaky. I don't want to just eyeball. It's like it's the same damn thing we did here.
Yeah.
Right? So let's get better here. Let's look at, I want to calculate something based on my graph. All the graphical stuff is up here. So if I want to calculate something based on this, where do you think I'll go?
Second trace.
Yeah, second trace to get into calc. There's calc right there. Second trace. Hit the second, like the shift key. And then, yeah, exactly. Then it's kind of obvious I want the intersect. So later this semester, we'll talk about the min and the max for finding out like where the maximum profit is or where the minimum cost is or whatever. These are calculus. So not surprising, we won't talk about those. So number 5, if you hit intersect, it's going to ask you 3 questions. What is your favorite color? No, it's going to ask you,
second curve.
what is your question? First curve, second curve. So here, let me just get right to the chase. Here's my first curve, right? I only have 2 curves, so it's kind of silly. Here's my first curve, enter. See how it comes down? And real quick, a little side note. In math, we call a straight line even as a curve. It's a straight curve. So you just leave us alone. If I pick the first curve, hit enter, it bounces down to the second curve already. You with me? It moves itself down.
Yep.
Then you hit enter. And then it says, what's your guess? So then you put it right on top of it. Enter. All right, 2, 1. Sweet, thank God. So our algebra is strong. Right? So kung fu. So what I always do, the shortcut, is when you hit intersect, just put the cursor right on the guess to begin with. Enter, enter, enter. You guys kind of with me? because it kind of answers the first two questions on its own. First curve, second curve, it moves around itself, and I'm already on the dang guess. Enter. With me? Little tiny note there, but I want you guys to understand that. So let's put something freaky in there. Let's put something in there that we can't answer by hand. And in fact, let's try to do it by hand first, and we'll see how bad we fail. That's not that bad. Let's make it. Let's make it 4x minus 5. No, that's bad. It'll come out nice. Leave it like that. That's fine. Okay, I'll get over it. So if we try to do this by hand, what's the y-intercept for the first guy? 4? And his slope is good. So I got to go up 1, 2, 3 over 1. I can also go down 1, 2, 3 back 1, right? 1, 2, 3 back 1. It's all the same line, right? Okay. Let's see. How do I do this? Oh yeah, so it's going to be over there somewhere. Shoot.
Timbuktu.
Yeah, up 3 over 1. All right, that's enough. So here's my line, my very, very questionably straight line. And then x minus 5, negative 5. So up 1 over 1, up 1 over 1. Right, so it almost looks parallel, especially with my horrible scale.
Oh, you didn't? You took 4 away from it?
See it?
You took 4 away from it?
1, 2, 3, 4, 5.
No. You put the 4. You said y equals 4x minus 5.
Oh yeah, I took the 4 away from it. Yeah. Sorry about it. Otherwise, that would have come out exactly right. I want it to be ugly. It's even uglier than I really tried because these two almost look parallel with my crappy picture. But it actually comes out. They're going to meet somewhere back here, and I'm not going to be able to find it because it's not whole numbers. Right, so it's going to come together at a point that's not exactly. If I do my slope down and over, it's going to be in between 2 points. I'm not going to be able to tell exactly what it is. But we can do this on the graphing calculator pretty simply. If I make this y1, make this y2. So go ahead and try to do that like we did this. Take these out of the way and put those in here. So what do you see if you do zoom 6? Can you see where they meet? Almost. It's a little off the screen there, just a little bit, right? I want you guys with me. So I could change the window a little bit to make sure that I see down that far. Currently, how far down can I see? Down to negative 10, right? I really need to be able to see maybe down to negative 15 just so I can totally see that on the screen. Are you with me?
Yes.
So how do I change the window? Probably with the window button. This is crazy. It's like a Denny's version of the calculator. So window button. Y min currently is negative 10. So let's make that negative 15. So now when I graph, it's going to be a little skewed downwards, right? So it goes a little further down. But now I can really see that. Okay. So go ahead and try to find that intersection using the calculation button up there, the calc button. You guys got it? So second calc, intersect. quick. You'll notice up and down just moves you between lines. You only can move around if you hit left and right. So enter, enter, enter. You guys with me? So it's not that ugly, but still I would not be able to tell that on my slope, my points would never match. It would be in between two, and I would know exactly where it was. Now I want to show you how even more powerful what we just did really is. I don't know if everybody realizes what we just did. If I ask you to solve this, let's see, what do you got, Jeff? Like that. Okay. How would you solve this by hand? Yeah, factoring eventually, right? What did you do first?
Get all like things together.
Good. Get this side equal to
0.
because of the square, right? So subtract all this stuff. I'll crap it half. Do me a favor. This is what happens when you try to do this and you make that a -3, all right? Everybody with me? Okay. So then make this x squared minus. See what I was going for there. Okay. And then
X equals 7 and -1.
7 and -1. Yay! Right? And that's a simple example of this kind of problem. It could be much worse than that. Right? And in fact, if I make the power much higher than 2, it gets to a point where we can't even do it. Or the answer is disgusting, and then you got quadratic formula, unless the power is too high. Guys, it's very simple to make this something that I cannot do by hand. Right? In fact, there's a lot of equations I can't solve by hand. A ton of them. There's just stuff. Can you solve this? Do you guys know natural logs and stuff? You guys done those? Some of you guys don't know.
Yes.
Don't remember.
But those of you who know, I cannot solve this. In fact, let me do it like that. It's even worse. I can't solve an equation where I can't get x by itself, right? If I can't get x by itself in some way, we did it here by breaking this up into 2 small problems, and then we can get x by itself. Are you kind of with me? Kind of with me?
Yes.
So if I have an equation where I can't do that, I can't solve it by hand. So here's a way. Let's solve this. We're going to solve this in the calculator. Put each side in. So make y1 equal to 2x squared minus 5x plus 3, or minus 3. Look at you, Jeff. We're stuck on that. And then make this guy x squared plus x plus 4.
Is it okay for the x squared if you put the x in the caret key too or no?
Yeah. Square, you could use a caret key if you want to.
Okay.
So I'm going to put that side in y1, that side in y2, and graphically, where are they equal to each other?
They intersect.
Where the curves intersect. Love
Oh.
it. So if I hit zoom 6, just to get all my window weirdness out of the way. Alright, so I can see one answer on the screen, right? Let me slow down. Let me help you guys.
What were we supposed to be putting on the second line?
So y1 is this side. You can do this with any equation you ever come across. Make this side y1, make this side y2, see where they meet. I don't know if you guys realize what I've just done for you. Any equation you ever see, ever, y1 is that side, y2 is that side, see where they meet, right? That's never going to be good enough for me as far as work. That is checking your work, if you want to. Got me? So you can check any equation I ask you to solve, you can check your work really easy. Now, what do I see on the screen there that relates to what we did here? Yeah, it looks like I can see the -1 answer for x. Yeah. -1 is the x value, one x value where they meet. The other x value where they meet, of course, is going to be It looks like they're getting closer together, so I have to do what? Yeah, window, maybe change what on my window?
Positive? I don't know.
What's the highest Y value I can currently see? 10. Now where does it say that here?
Y max.
Yeah, Y max is currently too small. So what do you think I should make it? I don't know. We could try 20. Let's do 30. Just going to say something. Make Y. Oh, look at me doing X max. Check. Some of you guys are like, should I say something? So here's Y min, here's Y max. Make Y max 30. These are the X's. I shouldn't do anything up there. Hit graph. There's that dude. There's that dude. And we almost see it. Damn. So just go back to window. It's like the Price is Right. Make it 50. Alright, there's that dude. Come on now, you gotta do it this time.
No, that's close.
Oh yeah. Alright, so make it 75. Come on, dude. Yay. Alright. And they can do a little zoom box around it if you want to, but we can see. So we can do the intersect thing like we did before, right? Second calc, number 5 is intersect. Do it here, we get -1. Do it over there, we'll get 7. Like we got there, you guys kind of with me? Alright, so we just learned something stupid powerful, right? But it's not enough. I've had people do this on there, show it work, and they say, well, I first hit this button. I've actually had people, so if you do that, now I'm not going to laugh about it. I'm going to cry. And then I'm going to take a lot of points off. Is there any questions on that whole thing there?
So, okay, using the map, since we've got the X, finding the Y's then.
Now, I'm glad you said that. I almost forgot. The graph graphs each of the outputs, all the outputs for these. All this equation says is, I want to know when the X value makes the outputs equal. So to answer this equation, do I have to say anything about Y? What the Y value is? This equation says, when are these equal? It doesn't say, oh yeah, and what are they? Right? The only letter that's involved here is X. So I really don't care that at 7, it's at whatever the hell it is.
Yeah, but what if you just wanted to figure it out?
Sure. And so when you do the
So
intersect...
you just put 7 into...
No, screw that. When you do on the calculator, when you put the intersect, it'll show you the whole point. It'll show you X equals Y equals, yeah. Now here you could just put a 7.
Yeah,
Yeah, just put a 7 in there. Yeah. That'd be like a check. Put a 7 in, make sure they equal each other, and you can see what they equal. Yeah. Cool. So real quick. So I do second calc intersect. I go up here. So put it right on top here somewhere. Enter, enter, enter. So get 7. So at 7, these are both 60. So if you put a 7 in, you'll get a 60. But all the equation cares is whatever they are, they're equal. So my answer would still just be 7 and -1 if I do the other one. The Y value has nothing to do with the answer to this equation. You with me?
Yes.
Because the Y doesn't even show up. Okay. Hopeful. Okay, cool.
Would we ever see anything like this?
Oh, hell yeah. Yeah, just to warn you, it's very possible I could give you an equation that you can't do by hand, and I can do that really simply. I mean, if I give you this thing, why is that basically impossible to do by hand? Yeah, it's a cube. If that was a square, maybe you'd be able to factor it. Maybe you could still factor it now, but we don't even know how. I don't know many of us know something called synthetic division. Probably not, but that's in our future, and it's really cool. But because that's a cube, I already know I'm probably not going to be able to solve this. And my x's don't cancel, so I can't just take the number over and cube root. If these went away, I could just take the number over and cube root. Ooh, I got it. But these x's don't go away. So now if you just put that, y1 equals that, y2 equals that. See where they meet. We're going to have a cubic tube. I'm going to have a line come flying in. Right? Might be one answer, two answers, or it could even be three answers. Right? Real answers. Be careful. There's always three answers, but they're not always real. All of them. Okay, maybe. Get a weird vibe from you guys today. Yeah, like you're telling us too much shit, Jeff. Just tell me exactly what I need to know. Okay. Okay. So let's get into section 10.3. Yeah, that would be the coolest thing in the world is if anybody here outside of class was playing with your calculator. That would just make me like, my head would explode probably. Normally students are like, I don't want to do shit with it unless we're in class doing stuff. Okay, cool. So 10.3, the reason I want to do 10.3 first is because we just did a section where we plot two lines and we see where they meet. This section is going to be not where one line equals the other one, but where one line is bigger than the other one. Something like that. Okay, so that's a little freaky. So remind me, real quick, how would I graph this on a number line?
X is greater than 1.
No, on a number line.
Put a 1.
Point.
Circle.
Yeah, what kind of circle?
A full circle,
no,
because it
Not a full circle.
Is it allowed to equal one?
No.
No, so it's got to be open.
Open circle.
Even better would be to use a parenthesis, because that more directly relates to interval notation, right?
Yeah.
So get away from open and closed circles and start doing those. But basically, it's some kind of open. It's not a complete thing. It's a parenthesis.
So if that
It's definitely not a bracket. I like it. Because a bracket would be if you include, because it looks like an eye.
Greater than or equal to.
And then where do I shade?
To the right.
Towards the right.
Good. Why do I shade that way?
It's an arrow.
I like it because it's an arrow. I like that one. That's a way to know. But be more, less shortcutting. Tell me, what is 2? Why is 2 included in the answers? Because when I plug it in, it's true. When I plug a 0 in, is it true? No. So everywhere I don't shade, and I'm over analyzing this to death because we're about to go to 2 dimensions, right? Everywhere I don't shade is not an answer. Everywhere I do shade is an answer. Right? Which kind of explains why we have this open circle. Is the circle shaded?
No.
Therefore, 1 is not an answer. Right? That's why we have a shaded circle and a not shaded circle. All right. Well, that's interesting. So what if I had y is greater than x minus 1? So what separates not answers from answers here? A point, right? Because they only have one dimension. How do you cut something one-dimensionally? How do you cut it at a point? How do you cut a plane? What shape do you make when you cut it? So I got my sword, right? And I want to cut this plane. What shape would I make if I cut it? A line, right? So I would cut a plane with a line, separate answers from not answers. Are you guys kind of with me? Okay, maybe. So it's not going to be as simple as obviously because we've suddenly upped our dimensions.
You just plot that, right? You're going to plot it and then
Exactly. So if I plot this line, and why do I know what I need to know for this line? Because I love it. Right? It's already solved for mx plus b form, so I know the slope and I know the y-intercept.
This is kind of if you had to move it, if it was x minus 1 equals y, or less than y.
Well, if it was y plus 1 greater than x, you solve for y. Yeah, because then you can see your slope and your y-intercept. I love it. So if I were going to graph just the line, okay, this is crappy scale, but too bad. What's my y-intercept? -1. What's my slope?
1.
So up 1 over 1. Now, be careful. Don't. Right here, when we plotted 1, did we put a circle there? Is there a closed circle?
Why not? Because x is not allowed to equal 1, right? Y is not allowed to equal this line. So I'm not going to make a solid line.
Dash.
I'm going to make a dashed line. It sort of correlates with the open circle idea, right? So I'm going to make a dashed line because the points on this line would not work here. The points on the line make y equal this. It's not allowed to equal that. How are we doing so far?
A little confused.
That's right. So this is one step away from just graphing this. We make a dashed line if I'm not allowed to equal the line. We make it a solid line if I am. Directly related to open circle, closed circle. Now the answers are all over here or over there. We actually do it the way we do it normally. We just don't, it's just so easy over here, we don't even think about it. 2 is bigger than 1, so that's the answers. If I put a 0 in, is it bigger than 1? No, so the other side of the answer. So if I just pick a point,
0, 0.
0, 0 is one you almost always try because those are the easiest inputs. So if I pick any point, and I always try to use 0, 0 if I can, and if it works in here, the answers are over there. If it doesn't work in here, the answers must be on the other side. You guys kind of with me?
Yeah.
It's an all or nothing thing here because it's an inequality greater than, it's got to be one side or the other. Personally, I just do it like this. Where are the y's bigger than that y? Up here. So I just shade up and I'm done because this is greater. But that gets a little weird. The steeper my line gets, there's no up and down. There's like left and right. And then what is greater and less than? It gets a little freaky. So you can always do the test point. If you throw a 0, 0 in here, what happens?
0, 0.
0 greater than 0 minus 1?
Yeah.
Is 0 bigger than negative 1?
No.
Yes.
Oh, yeah, it is.
It's Monday, so no, it's not. No, yeah. So that worked. That point worked. Which means every point over here would work. Same way, since 2 is bigger than 1, every damn thing on this side is bigger than 1. Because that's the dividing line. Here's the dividing line. That worked. Everything over here works.
So with you, do you care what we do? Do you want arrows pointing that way? And then
I don't care. You guys have lots of creativity. Colored pencils are not a bad idea. Especially when you have one line and then another line on top of it. Right? Oh, yeah.
That's when you have multiple ones, like 3. We're going to do like 3 lines, right?
Yeah, you could do infinite number.
So the dotted line means it's not inclusive.
I like it. So it's sort of like an
It's
open
solid,
circle here.
It's solid, so if you just made it y is greater than or equal to,
This would have
then the
been
line would be solid.
beautiful. I like it.
Nice line.
So if I plug the point 2, negative 1 in here, what's going to happen? If I did, no, don't do it. If I did, what should happen based on what we've done here? Will it work?
No.
No, because it's on the side of not answers, right?
Yeah.
Giants fans, Jets fans. So 2, if I plug in 2, negative 1, is negative 1 bigger than 2 minus 1? So plug a 2 in for x and negative 1 in for y. Is that true? False. No, so that's another test point to check.
Stay away from the false.
Yeah, stay away from the false. Sounds like poltergeisters. Stay away from the light. Okay. It's not too bad, right? So how can I make that worse? Well, and a real quick word on what's going on here. If you go into an elevator, thankfully this is not true. The first thing you look for is the little inspection thing, right? Inspected last time in 2007. Okay, I'm a little worried. But it always says on there somewhere you can hold a maximum of blah, blah, blah. Right? So that sounds exactly like this. The total weight could be less than or equal to some maximum amount. You with me? So if you have a situation where the weight has to be less than this and something else has to be greater than this. So that means you have to exist like in that little triangle there possibly. It's in real life we have a lot of constraints and I want to know where can I live. So if the most power I could put in, it's got to be more than this, but it's got to be less than this so nothing blows up, right? So then I'm like, oh, that's my safe area. So if I'm here, run, you kind of, so I know where my safe area is. That's an example, not a great example, I apologize for it, but that's one situation we use this for in real life. It's always a good idea to see where the hell is this got to come in real life. And of course, in real life, not everything's straight lines. I could have, it's got to be below this and above the parabola, so I live in there. Right? So it doesn't have to be a straight line, it could be all kinds of shit. We're just going to deal with straight lines. So what, here, you guys do this, and I'm going to throw something in on top of it. So try to graph that one out fully. Plot the line, shade. So what's the y-intercept? Yep. And then I go 3 over 1. I really just need 1 point here. All right. I'm going to graph. What kind of line is it going to be? Solid. What kind of line? Straight. And if you plug 0, 0 in, is 0 less than 0 minus 2? Is 0 less than or equal to negative 2? No. So I won't shade this way, because that didn't work. I'll shade this way. And the way I would do it, less than, I'm going to shade down, so that would do the same thing, right? You can do either way you want. Test point always makes it a little bit clearer. So what if the problem wasn't just this, but it had a second dude? So a system of linear inequalities. Right? So a system of equations, the answer is where they meet. A system of linear inequalities is where their shading meets. Oh, weirdness. So I'm being really nice here, obviously. In the book, in the homework and in the test, you're going to have to solve for y, but let's just get to the point. So what if y is greater than negative 2x plus 1? Now plot that on top of that dude. So, just like Chapter 7 required you to know factoring to be able to do it, obviously this section is going to require you to know how to graph lines to be able to do it. So what's this guy's y-intercept? 1. And then from there I go where?
Down 2 over 1. It could go up 2, back 1. It's the same thing, right? And then what kind of line am I going to make?
Dash.
Dash, I like it. And again, the only time I can't use 0, 0 as a test point is when my line goes through it. Because then it's like, it ain't going to tell me, crap, it's right on the fence. Right? I've got to use something that's on one side or the other. In this case, I can use 0, 0. Is 0 bigger than 1?
No.
No. So which way am I going to shade? Away from that, right? So not on the side that has 0, 0, but on the other side. So now where is the answer? Yeah, so then you come in on top of this stuff and just make this a little darker, right? To make that clear that that's the answer. So that's kind of like my safe area.
Can we just circle that area?
Okay. Yeah. Anyway, you make it clear.
Would it be counted wrong if we erased, obviously, like in that?
Oh, like took that away?
Yeah, and
That's
the top
fine.
part as well.
Some people would just kind of put an arrow there, and then an arrow there, and then they go, okay, where would those meet? And then they only shade there. That's fine also. So if you erase this or don't even put it there in the first place, it's fine. But I need to see something that shows me your thought process. You guys with me? Yeah, it's not that horrible. It's not bad at all. Yeah.
You said that you knew you could use 0, 0 for the second one. Why?
Just because neither line goes through 0, 0. So I'm allowed to use it. If it did go through 0, 0, I would just use like 1, 0. Or 0, 1 or whatever.
This is 10-3 still, right?
This is still 10-3.
Okay.
Cool. Okay. So look at the bottom page 652 real quick. Just to show you an example. So they had, you alright? I think somebody was talking about this. They have 3 lines that they gave. So they graphed 6x minus 2y equals negative 12. Looks like that's here. Y minus 3 equals 0. That's y equals 3. What kind of line is y equals 3? Horizontal. I like it because y is not allowed to change. So that's this dude. And then x plus y equals 0. That's this dude. Right, x equals negative 1. And so, I think the problem was above that. They have the inequality symbols. I didn't catch that on here, but you can see it in their book. So it had to be greater than this, greater than that, and less than this. So this is like I was saying, this would be the real-life application of this. You see this kind of thing, or something related to this, on work sites where you're dealing with electricity possibly, or loads on things, or like the elevator example. This is your safe area, right? If you ever see a point outside of there, you go running to whatever that thing is, and you figure out how it's set wrong or something, because that's the not safe area. How we doing? Good. Okay, cool. Just want to show you. So obviously in your homework, I think I assigned a couple of those kind of problems with several lines. So you just do what we did, one more line on top, boop, and then you got the little triangle area maybe. That's going to be the answer. How you guys feel about that? All right. I keep asking you this because a lot of you guys look like you had a rough weekend or a really, really good weekend. Blah, blah, blah. Let me make sure I didn't miss anything here. Oh, I'm going to be really careful. If I said graph, if I just said this, if I said graph y less than 2, and you did like a number line and did it, I almost can't complain. So I have to say graph y less than 2 on a Cartesian coordinate system.
or on the XY plane, right? Or in 2 dimensions. I have to be very explicit that I mean I want it in 2 dimensions. So how the hell do you do that? We basically just said how. What's the line that I'm dealing with?
Horizontal.
Yeah, it's horizontal. Y equals 2 would be horizontal here. What kind of line do I make? Dot. Dash, however you want to say it.
And it goes up right there.
As we were trying to say, horizontal, man. We just told you. So dash line, because I'm not allowed to equal to. And then this is really simple. Where are the y's less than that? Below. Is 0 less than 2 if I want to plug at this point in? Yes. Cool. So it'll be all that area there. Special case, it's going to be horizontal or vertical, and then you just shade left to right or up or down. Okay. Not too evil. Okay, you want to take a break? Right now or later? Right now, okay.
Sure.
I think now is probably good. Come back at 5 till.
I have a question.
Yeah.
I do something.
Oh yeah.
Towards the end, please try to go back to normal. And then
Oh, it's because it's going from 15 to 15, so it's like there's no area. So you got to go from negative 15 to 15. Or just hit zoom 6. And that forces you to go negative 10 to 10. So if ever your min is equal to or greater than your max, the calculator's going to freak out.
Okay, so then
You like circled that?
Not negative, just less than the max.
when you
You
factor
can
it
go
out,
2
it,
min, 5 max.
So I don't know.
Alright.
But you can't go 5 min, 2 max. It's like, how the hell flip the reality?
Yeah. All right, thanks.
Cool.
Homework corrections. I'm on them. You circled this and then question marks. I don't know if that means it's wrong, but I refactored it. Looks like I got it right. Maybe it's a canceling. I got the wrong answer.
What was my question? Oh, no, my question was the 2y plus x. I think you were okay with the factoring. There it is. There's your work. But I made too big of a circle. I meant just this. Why did that cancel? Because it's 2x plus y, so the 2x plus y should be canceled. Right? It looks like you canceled.
Okay, yeah.
So that's
exactly
what
I
threw
did.
the answer.
And then there's
yeah.
one on the front that says reduce. Do I just have to multiply that by negative? Because when
Take a
those are-
negative one out.
take
So I
a
was thinking about it
negative
as
one out.
factoring, because you're not allowed to multiply by negative unless you do the
Okay,
same thing on the bottom.
okay.
But if you just take a
that's
negative
that
out of
thing
one,
it's just equals a negative one if it's those two over
exactly.
each other.
So you could even just kill it and put a negative one there.
Yeah. Okay.
Beautiful. Oh, good. Thank you.
This work as far as finishing up with showing it, because this was the one I wasn't able to complete when you said turn it in.
Oh, yeah. So there's that, there's that.
And then we'll get, 2 brought down.
Oh, and then you
4, and then-
reduce it. I love it. It's perfect.
I got a couple of questions.